For the last few years, we've thought of AI as something we talk to, but there's this fundamental shift happening right under our noses, led by Anthropic, that's turning AI into something that acts. And I'm not just talking about a better chatbot. We're looking at a completely new agentic system built around something called Claude.me and these things called skills, designed to be an active player in your digital world. So let's break down exactly how this works and why it's so much more than just a new feature. This quote just nails it, right? The entire paradigm is shifting from a passive, let me look that up for you model to proactive task execution. And this isn't just about convenience, it's about fundamentally rewiring the nature of software and our role in using it. We're moving from being the operators, the ones clicking all the buttons, to being the delegators. So here's how we're going to break this all down. First, we'll look at the core problem with the chatbots we use today. Then we'll get into the new agentic architecture Anthropic built to fix it. We'll see how it actually gets things done, and then we'll zoom out to see the huge paradigm shift this is causing, the super clever open ecosystem strategy behind it, and finally, what the road ahead looks like for true AI autonomy. Okay, so let's start with the problem itself. For all their incredible power with language, the AI tools we use every day are, well, they're trapped. That trap is the chat window. A traditional LLM is basically a brain in a jar. It's totally sandboxed. It's reactive. You type text in, it gives you text back out. It can't just decide to organize your files or talk to your other apps or run some complex workflow without you holding its hand every single step of the way. Agentic AI, on the other hand, is engineered to just shatter that sandbox. It's proactive. It's designed to live and operate inside your environment and take real, tangible actions to get a job done. So how do you actually build an AI that can act? Well, this isn't just a simple software update. It meant Anthropic had to go back to the drawing board and completely reimagine the entire system architecture. And listen, this is the key insight right here. This is not just a fresh coat of paint. It is a deep, fundamental re-architecture of the AI stack. It's all about giving the model a body to act with, senses to see its environments, and a whole library of abilities it can use. Let's look at those three core pieces. First up is the platform, which is Claude.me. Think of this as the AI's body. It's how it's physically present in your digital world. And it's not just some web page. No, it's a persistent environment, like a virtual machine that has its own file system and its own terminal. This is the ground where Claude can actually run commands and move files around. Next, you have the skills. So if the platform is a body, skills are the muscle memory. These are the abilities it's learned. And a skill is way more than just a prompt. It's a whole self-contained package, literally a folder with instructions and code that teaches Claude how to do one complex thing really, really well. Think of it like a playbook for how to refactor a Python codebase or how to generate a market analysis deck. And the one orchestrating all of this is the model itself. This is the brain. It's the Claude we already know, but its job description has totally changed. It's now a reasoning engine, a master strategist. Its job is to take your high-level goal, break it down into smaller steps, and then pick the right skills in the right order to get it done. So here's the whole mental model in one place. You've got the model as the brain, the reasoning engine. You have the skills, which are the library of things it knows how to do. And you have the platform, which is the body that lets it interact with the world. This three-part structure, separating the brain from the abilities from the body, is the fundamental design that makes all this autonomous action even possible. Okay, so we've got the architecture down, but how does it all come together in practice? How does Claude actually take a task from start to finish? This chart just lays it out perfectly. With the old Claude.ai, you have a chat. With Claude.me, you delegate a task. One lives in a temporary browser tab, the other has persistent memory and works on your actual file system. But the most critical difference is the execution style. It goes from synchronous, where you're waiting for an immediate reply, to asynchronous. You can give it a massive task, walk away, and it will just keep working in the background for hours, maybe even days to finish it. And it does this through what we call the agent loop. So you give it a goal, something high level, like analyze these sales reports and build me a presentation. The model thinks, and then it picks a skill for data analysis. That skill runs, maybe executes a script, the system gives back a result, the model looks at that result and decides the next move. Okay, now I'll grab the PowerPoint creation skill. And it just keeps looping like this over and over, all on its own, until your presentation is done. Now you might be wondering, how can the model know about hundreds of skills without running out of context memory? And the solution is just elegant. It's called progressive disclosure. When a task starts, the model only sees a simple list, just the names of the skills and a one-line description. It's like scanning a table of contents. Only when it decides, okay, I need this skill right now, does it actually load the full chapter into its working memory. It's a brilliant way to make the whole system scalable and super efficient. So, look, this whole architecture is way more than just a clever product design. It's really a blueprint for a brand new way of thinking about how we build and use software. For the last 40 years, pretty much all software has been built around a graphical user interface. It's made for a human to click on things. But in this new agentic paradigm, that gets flipped on its head. We're moving to a world where software is designed first as a set of capabilities, or APIs, that are meant to be used by an AI agent. The pretty interface for us humans, that becomes a secondary, optional layer. The primary user is now the AI itself. And this isn't just a theory. It's already driving massive adoption in the business world. Projections are showing Anthropic's enterprise market share more than doubling, and it's largely because of this agentic strategy. Why? It's simple. Businesses don't pay for conversations, they pay for outcomes. They want an AI that can reliably automate complex workflows, and this architecture is built from the ground up to do exactly that. But building this powerful architecture was only half the battle. You could argue their most strategic move wasn't the tech itself, but how they decided to open it up for everyone to use. They did this with something called the Model Context Protocol, or MCP. The easiest way to think about MCP is like a universal translator for AI tools. It's a totally open standard that defines how any AI model can talk to any external tool, whether that's querying a database, pulling designs from Figma, or firing off an email. This timeline shows a brilliant bit of strategy. See, OpenAI was first out of the gate with its own proprietary function calling. But Anthropic played the long game. They released MCP as a true open source protocol, betting that an open standard would grow the whole ecosystem way faster than a closed one. And boy, did it pay off. Within months, their biggest rivals, OpenAI and Google, adopted it, which basically made MCP the industry standard overnight. So here's the bottom line. By creating an open protocol instead of just a proprietary feature, Anthropic lifted the entire ecosystem. Now, any tool built to use MCP works with Claude, it works with GPT, and it works with Gemini. That's a huge deal for developers, and it makes this whole agentic world more powerful for everyone. Now, as exciting as all of this is, we've got to stay grounded. We are still at the very beginning of this agentic era, and there are some pretty significant hurdles we still need to clear. These are pretty much the 4 big ones today. Those reasoning loops can get really token intensive, which means they can get expensive. Latency, the lag time, can make real-time interaction feel a bit slow. Vision models still aren't perfect, which can cause hiccups in desktop automation. And of course, getting true long-term memory right is still a major challenge. But the good news? These are all solvable engineering problems, not fundamental laws of physics. And while those challenges are real, people are working on them like crazy. The foundational shift from conversational AI to agentic AI, that's already happened. We are now officially in the era of AI that does things. The question isn't if we'll have AI partners that can handle complex tasks, but what we're going to empower them to do. So the real question I want to leave you with is this. What is the very first skill you are going to teach your AI?